In this section, we're going to look at triangle congruence by ASA, which is angle, side, angle, and AAS, which is angle, angle, side. Again, we're going to look at some postulates that will help us prove that two triangles are congruent to each other. So the first postulate is postulate 4.3, which is angle, side, angle, and the short form for that is ASA postulate. This postulate states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So here in our example, we can see that first we have two congruent angles. We got angle A is congruent to angle D, and then angle C is congruent to angle F, and then the included side. When it says included side, that means the side in between the two angles. And here you can see the side in between angle A and C, the side between angle A and C, which is side AC, is congruent to side DF. And because of this, we can come to the conclusion that triangle ABC is congruent to triangle DEF. The next theorem we're going to look at is theorem 4.2, angle, angle, side. The short form would be AAS theorem. So the theorem states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So here in our example, we can see that angle A is congruent to angle D, and angle B is congruent to angle E. In this case, however, the side that is congruent in both triangles is not in between the two angles, but actually on the opposite side of the included angle area. What you have to keep in mind is that both the sides have to be corresponding. And because of this, we're allowed to come to the conclusion that triangle ABC is congruent to triangle DEF.